All right, in this problem, we are satisfying the objective. I can determine the final path of a light wave which has been reflected and refracted along its path. So we have this setup here of a light wave coming in at this angle 30 degrees from the air, and getting both refracted into quartz and then reflecting off the boundary here between air and quartz. So some things to keep in mind is that the index of refraction for air is 1.00029, and the index of refraction for quartz is 1.46. And our key equation here is Snell's law, which is n1 times sine of theta 1 equals n2 times sine of theta 2. And our first question is, what is the angle of refraction through the quartz if theta 1 equals this 30 degrees we see here? So we are going to just plug our values into this equation and solve for theta 2. That is our angle of refraction through the quartz that we want. This is obviously not drawn to scale. So we have the refractive index of air as our n1, sine of theta 1 equals the refractive index of our quartz times sine of theta 2, which we're also obviously solving for. So we set this in terms of sine of theta 2, take the inverse sine of that, and we get 22.033 degrees. Second question is a little more conceptual, but does the light reflected experience a phase shift? And the answer is yes. So always when we go from when light waves is reflected off a higher index of reflection, we get a phase shift of pi.